In this video, we're going to focus on how to name aromatic compounds, specifically benzene derivatives. So here are some parent names that you just have to know. You got to commit this to memory. The first one is phenol. It has an alcohol group. This is called aniline. It has an NH2 group. This one is simply nitrobenzene. And the next one is benzaldehyde, which I don't really have space to write that there. This is called anisole. The next one is benzoic acid. And then you have toluene. And when you have two methyl groups, it's called xylene. Let me see if I can fit benzaldehyde here. Okay, so I'm going to use these names throughout the video, so feel free to rewind the video if you're wondering, hey, where did that come from? So let's go over some examples. So let's say if we wish to name this compound. Now, the parent name is phenol. So we're going to make this carbon 1. This will be carbon 2, carbon 3. So this is called 3-chlorophenol. Now, it's also known as metachlorophenol. Here's something you need to know. For benzene rings that have two substituents, if they're disubstituted, ortho, which will be signified by O, is 1,2. Meta is associated with a 1,3 connection, which the alcohol is on carbon 1, the chlorine's on carbon 3, so that's why it can be called metachlorophenol. And the word para relates to the 1,4 position. So let's say if we have this particular compound and we want to name it. This is on carbon 1, 2, 3, 4. So this will be called 4-bromo, and then the parent name with the COOH group, that's a carboxylic acid. So we said it was benzoic acid. So this is called 4-bromo benzoic acid. Now, 1,4 also was associated with para, so we can also call this para-bromo benzoic acid. Let's look at another example. Now, a methyl on a benzene ring is called toluene or toluene. I always pronounce that wrong sometimes, but it's one of those. Let's say if we have a fluorine atom here. So this is carbon 1, this is carbon 2, because toluene, the CH3, is part of the parent name, so it has to be carbon 1. This is called 2-fluorotoluene. Or we can say ortho, which is 1,2, orthofluorotoluene, or toluene. Now, what if we, there's some other disubstituted examples that we need to go over. And this is the one associated with xylene. We said xylene at the beginning of this video has two methyl groups. But there's three forms that you want to be familiar with. Now the first one, it's the methyl groups are 1,2 apart. So this is called orthoxylene. In this structure, they are 1,3 apart. So this is going to be metaxylene. And here it's the first one is on 1, the last one's on 4. So 1,4 is associated with para. So this one's called paraxylene. Now what if let's say if we have more than one substituent. How do we name it? So let's say if we have, let's use benzaldehyde this time. And let's say we have a chlorine and a bromine. Now, which direction should we begin counting? We know this is carbon 1. should we count clockwise or counterclockwise? Or, well, let's say if we counted clockwise, the chlorine will be on carbon 3 and the bromine will be on carbon 4. If we count it in the other direction, this will be 2, 3, 4, and then 5. Chlorine will be on carbon 5, bromine will be on carbon 4. So which one is better? 3, 4? Well, let me put it in a different color. 4, 5? Or 3, 4? Well, 3, 4 gives us the lowest number, so we always want to count in a direction that will give you the lower numbers for the substituents. So we need to count it this way. If we count it in the other direction, we're going to get high numbers, so that's the wrong way to count it. Now, so we have a 3-chloro and a 4-bromo. Now, whenever we're putting these substituents into a name, you have to place them in alphabetical order. So bromo comes before chloro. So this substance is going to be called 4-bromo dash 3 dash chloro, and then the parent name, benzaldehyde. Let's look at another example. Let's say if we have this. This is anisole. And let's say if we have a bromine, and let's use the iodine. Now, if we count it in this direction, 1, 2, 3, we're going to have a 3-bromo and a 5-iodo. If we count it in the other direction, 1, 2, 3, 4, 5, it's 3-iodo 5-bromo. So either way, we're going to get a 3, 5 going counterclockwise, or if we count it clockwise, it's still going to be a 3, 5. So which is the right way to count it? Well, let's name it both ways, and then we can make our decision. In blue, I'm going to use the clockwise direction. So we have 3-bromo 5-iodo. Bromine, B comes before I, so we got to put that first. So it's going to be 3-bromo. We have to alphabetize it. 5-iodo, and then the parent name, anisole. And now if we count it in the other direction, we still have to place the substituents in alphabetical order. But this time it's going to be 5-bromo, 3-iodo, anisole. Now we have a choice here. Which one looks more acceptable to you? 3-bromo 5-iodo or 5-bromo 3-iodo? In both cases, the letters are alphabetized. They're placed in alphabetical order. If we have the option, should we put the numbers in increase in order or decrease in order? It turns out that after placing the substituents in alphabetical order, if we have a choice, we need to place the numbers in increase in order, which means that we need to count in this direction, because we get the same numbers but in increase in order. So this is the proper name for that particular compound. Now let's say if we have multiple functional groups. Let's say if we have a benzoic acid, a an OH, and an amine, and an NO2. How do we name something like this? I mean, do we use the NH2 and call the parent name aniline? Do we use the OH and call it phenol? Or do we use the carboxylic acid and call it benzoic acid? Or do we say nitrobenzene? Whenever you have multiple groups like this, you need to know which one has the highest priority. Now, most textbooks, they don't really give you a list, so you're not really tested on this as much, but the main two that you are tested on is carboxylic acids and aldehydes. If you see the carboxylic acid, automatically you're going to give that the highest priority. So the parent name for this is going to be called benzoic acid. If the carboxylic acid is not there, the one that's next in line is the aldehyde. That's going to be number 2. After that, it can vary. I mean, I haven't seen a good system that says, okay, the alcohol has more priority than the amine or so forth. I mean, at that, you just have to use good judgment. I don't know what to tell you about that. But if you see a carboxylic acid, that's going to have the highest priority. And then the aldehyde. So we know the parent name is benzoic acid. So in the last example, we see that bromine was bromo, chlorine was chloro, fluorine was fluoro, iodine was iodo. But what's OH? What is the name of OH as a substituent? We can't say phenol because the parent name is benzoic acid. Here's what you need to know. OH as a substituent is called hydroxy. Let me write that there. NH2 as a substituent is called amino. And NO2 is just nitro, which you're already familiar with. So now we have to number it. There's only one way to count it. 1, 2, 3, 4. If we count the other direction, we'll get higher numbers instead of lower numbers. The last thing we got to do is put this in alphabetical order. So A comes before H and H comes before N. So we're going to say 3 amino dash 2 hydroxy dash 4 nitro benzoic acid. Now you might be wondering, okay, when do I use a dash? When do I use a comma? When do I not use it? Because between nitro and benzoic acid, we didn't use a dash or a comma. Whenever you're separating a number and a letter, you need to put a dash in between. When you're separating like two numbers, let's say like 2,2-dimethyl, you put a comma to separate two numbers. Here we don't need anything because we have two letters, O and B. So we don't need a dash or a comma. Comma is used to separate two numbers. A dash is used to separate a number and a letter. Let's go over another complicated example. This time we're going to use benzaldehyde. So you'll see it as CHO, or sometimes you'll see it written this way. So let's use some different groups. Let's use this one. Let's use that. And what else did we not use yet? We use amino, we use hydroxy, we use nitro. I think we covered everything except the OCH3 groups. Alright, so let's number it. This is going to be carbon 1, 2, 3, 4, 5. We know Cl is called a chloro, and CH3, it's not going to be toluene because it's not the parent. It's not part of the parent structure, so this is going to be methyl as a substituent. But what about anisole, the OCH3? OCH3 as a substituent, think of like hydroxy OH, but instead it's going to be methoxy because of the CH3 that's attached to the O. And this one is going to be ethoxy because you have an ethyl attached to the O. So now we need to put this in increasing order. C comes before all of them. And then we have E. And then here we have M and M. Which one will come first? So METH, that's the same. So we need to compare the O versus the Y. So this O, methoxy, should come before methyl because that has a Y. O comes before Y in the alphabet. So let's name it. So this is going to be 3-chloro, and then this is carbon 5. This one is carbon 6. Almost got confused there. So 3-chloro, 5-ethoxy, and then we said methoxy comes before methyl. So 2-methoxy, and then dash 4-methyl benzaldehyde. So that is it for my review of naming aromatic compounds, particularly benzene derivatives, and hopefully this gave you a lot of insight in terms of how to name it. So that's it for this video. Thank you for watching.